Hello, my name is Kurt Ameringer. I'm a business value expert with the infrastructure, energy, and materials industry based out of the west coast of the United States. Introduce my colleagues, Yarub and Jonathan.
So hi, my name is Yarub AUDI. I'm industry process expert within CATIA brand. I'm based in Paris and I'm focusing on the construction and infrastructure market.
Hello, and my name is Jonathan Asher. I'm the portfolio director for the CATIA construction organization, part of the R&D group, and I'm also based in the Paris region, France.
Excellent. Well, I'll get this started. So I'm going to start off today by focusing on some of our perspectives and defining some of the challenges that we found in civil infrastructure. So I'm going to start out by outlining some of the challenges we face today. So I'm sure most of you are aware the infrastructure industry has been somewhat resistant to any change of tools, technologies, and process for delivering capital projects and operating assets. And we're finding that BIM, which was really purpose-built to deliver drawings for the building industry, has proven to be woefully inadequate to serve the large-scale demands of infrastructure projects. This quote you see here on the screen was taken from an excellent article in AEC magazine last year. And if you have a time, it's a very interesting read. But basically, it's outlining that the challenges of BIM is that we've really seen a stagnation of the original aims of moving to a model-centric approach. So I won't read it to you, but please do take the time to investigate online, as it is a good read. So what we're hearing from customers about what's driving them in the market today. Well, when we look at the sustainability market and the market research that we've pulled together, it's telling us that transportation accounts for roughly 20% of the global CO2 emissions. Road travel, that's 3/4 of that. Most of this is coming from passenger vehicles, cars, buses, and that's contributing 45% of the CO2 emissions for transportation. The other 30% is coming from freight. By contrast, rail is only accounting for about 1% of global CO2 emissions in transportation, and that's 0.2% of the total global CO2 emissions. So we're starting to see a migration from these passenger vehicles and from freight trucks into taking advantage of rail at a global scale. Something else I suspect we're all aware of regarding the project spend on these activities is that roughly 20%, or sometimes even less, of project cost is typically spent in planning, design, and construction. And this is leaving 80%, again, round numbers, of life cycle cost operations. So owners are looking at improving operations and maintenance costs because it has a greater impact on the total cost of ownership. So based on this, owners are looking to accelerate each phase of delivery of capital projects to improve overall performance. They're moving to more collaborative agreements and operating models, such as integrated project delivery or project alliances, rather than the traditional construction practices. Under these new models, key partners, the owner, the engineer, the manufacturer, the contractors, are all working together during pre-planning to develop the project scope, the schedule, and the budget, again, in an integrated fashion. These parties are forming a single contract that includes a no-fault clause, and they're operating under a joint management structure that governs the project execution. Early studies in this space are indicating that these agreements have resulted in 15 to 20% improvement in cost and schedule performance compared with traditional delivery contracts. And I'm expecting that we're going to see a number of these rise as teams learn to work together more efficiently. And if we start thinking about designing for operations, so that is engaging not just the contractors early on, but also the O&M teams during planning and design, I think we can deliver a more robust solution with fewer surprises in construction and fewer surprises over the life cycle of the asset. And finally, I think we're starting to see today that skilled labor is leaving the workforce really at previously unseen numbers, and a large number of others are retiring. So in short, there's a deficit of young skilled labor that's entering our industry. And according to a Construction Outlook survey by the AGC, the Association of General Contractors of America, in 2020, 80% of construction firms in North America are currently having problems filling both salaried and hourly positions within their teams. And over 70% of those firms are expecting this to be their biggest challenge. So more so than supply chain, which is challenging, the aspect of being able to bring in labor is becoming a big piece of this that we really need to find a way to overcome. So that being said, if we look at this project delivery process, I think you're probably familiar with the traditional means, which typically consists of segregated silos of knowledge and expertise. Risk has been individually managed by each participant and pushed downstream as much as possible. Most of the work is still paper-based, and existing contracts encourage really this kind of unilateral effort that is not sharing. So that's limited collaboration to manage risk and liability. By contrast or by comparison, collaborative project delivery is assembling key project stakeholders earlier in the process to form an integrated team. These partners become stakeholders within the entire project, working together to engage in mutual trust and mutual respect. Risk is collectively managed and appropriately shared across the team, and this collaboration encourages, it really fosters, it promotes, it supports this multilateral open sharing of collaboration. So where one succeeds, everybody succeeds, and financially everybody wins. So to engage in this, a large portion of our market today is asking for what's been termed a common data environment, CDE. But most of the solutions that we're seeing in the market today, again, we're hearing from our customers, are really just file vaults that are gathering all of the information into a single or sometimes multiple locations. They're cloud management of this information. And we're approaching this in a very different perspective. In the same case, there's this push in the market for the digital twin. And I just want to be very specific of the distinction of what we're doing with this idea of a virtual twin. A digital twin is typically this project or product-centric approach that describes the what. Okay, it's purpose-built, possibly for producing drawings, maybe capturing existing conditions, maybe sequencing, construction assistance, whatever that case may be. But typically, it's not easily used for a purpose other than it was initially designed to do. Meaning, you can't use a documentation model to easily run a construction simulation without significant rework to these digital twins. A virtual twin, the distinction that we want to make, is process-centric. It can describe the what, the why, the how, the when, the who, all of the other information around this. And it provides information to be able to specify, to coordinate, to procure with more precision and control, ideally offering more value-added services over that project lifecycle. So it's also capable of exporting digital twins, creating those artifacts, that moment in time that's for single use. So we're not limiting our ability to do that, but we're able to provide information as multiple means as the team needs it. So, but again, those artifacts are static information. What we're doing with our 3D experience and the 3D experience twin is capturing all of the information and making it accessible as a living, breathing part of the project that can grow with the project and continue to add value for the life of the asset. It provides a foundation for more efficient collaboration and enables better communication across the value chain. So all of this enables us to tackle a much higher level of complexity at the end of the day with fewer resources. So finally, our intent is to improve productivity for everybody involved in the project, to position this integrated environment to connect all the project teams, all the project phases, to be able to foster collaboration, orchestration, data-driven decision-making along the entire value chain and really the overall life cycle, again, of that asset. And particularly, this enables us to accelerate each phase of delivery of these major capital projects, connecting, again, from need all the way to operations with one continuous data stream on the 3D experience. So with all that being said, I'm going to turn this over to my colleagues to hopefully make a little bit more sense of what I've just said and show you some examples of how this is working today. Thank you.
Thank you, Kurt. So I will take the next session. So in my session, I will show 3 customer experiences to illustrate really more the scope of the CATIA through the 3D experience and the value that our solution for transportation infrastructure could provide. So first experience is with our customer in China, CRDC, China Railway Design Corporation. where the mission of this, of the platform is to accelerate design and construction of the railway network. So CATIA helps, in fact, them to increase design efficiency in order to improve their win rate, their productivity, and the better estimate of the constructability of their project. So it allows also the design team to decrease the manual processes, errors, and reworks also during the construction phase by the automation also of the design. So we see at the left of the screen that in 2008, China used to have a few hundreds of kilometers of high-speed rail, and today, if you see just below, that they have in fact the largest in the world with more than 16,000 miles of rail network. So